My name is Tom Strywall. I'm the principal investigator at, well, first of all, I'm a professor of psychology at California State University, Long Beach, and I'm PI for the Center for Human Factors in Advanced Aeronautics Technologies. I think our center is, first of all, we're a new center. We're a Group 5 center, so we've just been in existence for about 2 months. But I think our center is probably different from most of the others in that we're not focused on space. We're focused on, well, I suppose you could say we're focused on near airspace because we're interested in the national airspace system. We're interested in commercial transportation. So we've been working, prior to the award, we've been working with the Flight Deck Display Research Lab at NASA Ames with Dr. Walter Johnson. And we conduct airspace simulations using next generation air traffic management concepts. So we have kind of a unique capability. We have a simulation facility, we have some NASA software. We can play in a simulation with NASA Ames, and we can have our students in Long Beach, and they can serve as either Confederate pilots or Confederate air traffic controllers. And NASA Ames will actually have commercial pilots who will be flying in the simulation. So we can evaluate advanced controls, and we can evaluate advanced air traffic management concepts. So from a technology standpoint, what we're doing is looking at what's called the next generation air transportation system. And this would be the system that's supposed to be implemented in, I believe, 2025. And the idea is that we could increase air capacity and without sacrificing safety by implementing new automation tools. And in psychology, one of our areas of expertise is what's called human factors. Human factors has to do with designing tools or designing technology that's compatible with the humans that will use it. And so what we're interested in when these new technologies are going to be introduced, say in an airplane cockpit or in an air traffic control center, how should they be designed so that they take advantage of human capabilities, so that they're easy for the humans to use. We've had many students already come through our lab. Students usually come and initially serve as what we call pseudo-pilots. And as a pseudo-pilot, they learn a little bit about how to fly an airplane. Now, I don't think I want them flying an airplane I was actually in, but they're able to use the communication systems of the airplane, and they use the navigation systems of the airplane. They learn to talk like a pilot or like an air traffic controller, and communicate with real pilots and air traffic controllers. And as they become more proficient with the airspace, the operations, then we bring them in and introduce them to some of the human factors issues. And we expect our students to eventually become experts and to do research in the areas of human factors as it applies to these aeronautics problems and the problems with new automation.